Hello and welcome back to another coding session with Mr. Jacob. Today we want to further work on our console PixelLoop renderer. As you can see, I've already opened up the demo from the last time, and as you can see, even though this is quite small, it is running in my terminal. So the reason for it being a little bit small today is that when we are rendering to the terminal, we are of course limited by the size of the terminal window and the character size and so on. So we only have a specific amount of pixels to work with. And today I want to build a little game, specifically a breakout game with you together within or using the PixelLoop engine within our terminal and using all the work that we did the last time. This is the more or less automatic demo that we have implemented and then optimized in the last two videos. You can see its implementation, which I've linked right there in the corner. And after that, I will link the optimization video as well. You can, of course, as always, find the links in the video description as well. So what I did off screen, because I thought it might not be very interesting for you, is I've implemented, as you can see by these violet box there moving, I've implemented user controls so that we are capable of using the keyboard to get events from that in order to move something around. And let me quickly show you how this actually works, and then we will get right into it and implement our breakout game. So let me quickly switch to Visual Studio Code and let me open up the trivial CLI demo. And just for you to see how this input controls work is that we are now getting in our update and our render functions, we are getting another thing here that is an input state implementation. It's actually only a trait that is implemented then for the different canvases or different environments. And I've made an implementation for cross-term, which simply uses the cross-term based ways of getting keys up and keys down and handling them properly. And the way that this actually then works is we can simply ask this thing if a specific key is up or down. So in this case, we can ask it if the the up key is pressed down. So then we want to change the position of this user controllable box that we have in our state. If the key down is pressed down, we want to change the position as well, but in this case we want to add one, otherwise we want to subtract one. And the same thing for left and right. Another thing that I've implemented here is I've added a check if the key Q is pressed. Pressed is different from being a key that is down. Down is, it will always be registered as down as long as you press it. While a key pressed is only if it has been pressed once before this update cycle here happens. So if you just pressed it. So for all those one press commands, like we want to execute some action, but only once we want to use is pressed. And that's actually all the magic there is to it. We can simply use this import here now to do things based on keyboard presses. So I guess we could go and start with the implementation. Let me quickly move my editor into the Zen mode, which I've forgotten here, unfortunately, so that we have a little bit more screen real estate and a little bit less annoying stuff around it. Okay, so what I've done here, I've simply created a new empty placeholder for our breakout game, which we will call Shell Smash. I've decided on that. So what I've done here, I have an empty state, as always, with our PixelLoop engine. The video for the PixelLoop engine will be linked there. We developed this on the channel as well. If you are new here, welcome, and if you are interested, take a look there. If you are just coming by, as always, if you like those videos, please give it a thumbs up and please hit the subscribe button, which really helps me in reaching more people and even more people enjoying and seeing those videos. Okay, so we have an empty state here, which is our application or game state, which is currently, there is nothing in it. We will need to add something in the future. And then I've just copied out the initialization code we already have from our easy example before, the trivial example. So what we have here is we are determining the current height and width of the terminal, creating a new canvas with set width and height, which is a cross-term canvas. It's our rendering canvas for the terminal. If you followed this video series along, you know that the PixelLoop engine can draw to WGPU-backed canvas in a window as well, but we are drawing to the terminal. So then we are doing something specific that I've created in the meantime as well. As I've said in the last session, where you have seen that we are rendering about like 40,000 frames a second, which is a little bit more than we need actually. I've implemented a very simple frame limiter, which simply waits between frames if they are rendered too fast, to then in the end reach the 120 frames. We have set the limit here too. So we are simply limiting the frame rate to 120. We are then initializing a new state, a new cross-term input state. That's the thing I've talked about before, so that we can handle keyboard events. We are just outputting the render size there for debugging purposes. And then we are starting our usual pixel loop here, 60 updates per second. We want here again in our update function the width and height, and we have the is key pressed. So if the Q is pressed, we want to exit. That's just to have a nice little feature for exiting our terminal application. And then we have our render loop here, which simply clears the screen to be black and renders out our canvas. That's all actually. More there isn't more. So this is really a very simple boilerplate that we can now start and fill with life to get going. But first, let's see if everything works and if we compile and start that thing. So let's go back to our command here and simply replace. I know you may not be able to see much on my command lines today because we will need the space for our breakout game, as I've already pointed out. So let's run the shell smash binary here. It is compiling, and as you can see, it is simply a black screen. So it initialized and cleared the screen, and then it initialized with a black screen. And now let me press Q, and if I press Q, I'm back at my prompt. So everything worked so far. Okay. So let's get going. We want to create a breakout game. A breakout game, kind of. I hope most of you will most likely know what a breakout game is. Why can't I create a new terminal here? Breakout game. Let's quickly simply search for some images of a breakout game. And yeah, that's something you might be familiar with or not, but I guess most of you are. It's simply that you have a couple of bricks somewhere in the game, and you have this, I don't even know what it's called. Is it called a pedal? I guess it's called a pedal. You have this pedal that you can move horizontally left and right, and then you have a ball that is flying around here to the bricks, and if it hits one, it will actually make it go away. You get points and so on, and you need to catch the ball is reflected by those bricks, and it is reflected by the walls of the screen, and so you have to catch it every time it is about to reach your pedal again and deflect it back so that the game can go on. And that's actually something that we want to implement now, or try to implement. We will see how far we are getting here in this video. So let's, in the shell, of course, in our terminal. So let's get going. Yeah, so I think the first thing that we need is a pedal. By the way, I have the I have the correct cup here today. Okay, so let's start with the pedal. Struct pedal, and I guess the pedal will need as most of our elements in this game, it will need a position, I guess. So I'm not sure how to store this position yet. Let's maybe say it's a usize. We will definitely need to convert between elements there and types there, because the rendering engine, the PixelLoop, takes a little bit different kind of data structure there. I want a size or dimensions. So dimensions or dimension, which will be a usize and a usize as well. And yeah, I guess maybe a color, so that we can actually put or make it a certain color. So let's start implementing a pedal. So what we need first, I guess, is a pubfn new, which returns a self. Let's see, should this provide, should this take something like its color and its dimension. The position will always be in the center at the screen on the bottom or something like that. Yeah, I guess so. So yeah, I would say let's take maybe width, usize, and height. Come on, usize, and maybe a color. Yeah, let's give it a color here so that we can determine that actually. And then we will return that self, and it will be position, which will be to be determined, I guess. So we will need a way to determine that. Let's maybe create something like let's maybe for now create two constants, call them play field width. They are your usize, and this would be don't know, 100 pixels, and something like play field height, it's the usize as well, and make it 100 as well. So we have a square play field, and we can make those things dynamic in the future, but for now let's just start like that. As always, let's start easy and let's get something going there before we make it nice. So I guess then we can determine the position already, because the position then would be, let's see, the play field, not height, but width divided by 2 minus the width divided by 2. Yeah, this should actually work, and I need to put a comma here. And then for the vertical position, we want it down at the playfield height mark, but the playfield height mark minus its height. Yeah, because the 0, 0 point is at the top left position in our engine, and therefore we need to do it like that. Then we need dimension, which is, I still think I should call this dimensions. Let's call this dimensions, because otherwise I will always type dimensions there and it won't work out. So the dimensions is actually the width by the height. And then we need the color. We simply can take that from our input. So now we are able to create a pedal. So I guess let's do that. Let's add a pedal to our struct. So this is a pedal now that the struct, the state holds. And we will create a pedal, come on, new, which I don't know. It should definitely be of an odd width, because then we can easily really center it. So maybe we do something like, no idea, 17 for the width, and the height maybe 2 or something like that. And color, maybe, do we make it simply white or yellow, or let's make it white for now. So 255, 255, 255. Okay, so now we have a pedal. Okay, then we need a way to render that pedal. So I would say in our render loop here, after clearing the canvas, maybe you should we should draw in our game area of 100 by 100 so that we can see more easily where everything is. Yeah, I guess we can do that. So let's do that. Fill rect. So we want to draw from 0, 0 to playfield, not height, but width, and playfield height and color. Yeah, maybe something like, can you even see that? No, you can't because my face is in the way. Okay, from RGB, maybe let's do it grayish. No idea. We will see in a second if this even looks good or not, and we need to provide the color as a reference. Let's reformat and let's see. So filled rect expected U32 find. Okay. So that is what I meant with we will need to convert data, I guess, because the sizes are to be U32s in our canvases. Yeah, I know. I've decided to do it this way in the beginning. Maybe it wasn't a good idea. Maybe I will refactor it in the future. Okay. So now we should actually, maybe let's try that. We should be able to see our 100 by 100 canvas. Okay, there is our 100 by 100 playing field. That's already working out nice. Okay, so maybe we could, where were we? Yeah, we wanted to implement our rendering of the pedal. Yeah, so let's get the pedal from the state and simply do maybe calling a render on it and giving it a canvas. Actually, that should work, and maybe shortcutting errors here, so we're expecting it, errors there, and then let's simply implement a render function on our pedal. So pub fn render, and it takes a mutable, no, it's the other way around, isn't it? And it's even more complicated because we need to make it dynamic, generic. So what we want here is any kind of canvas implementation, and this would be canvas, and we want a mutable reference to set canvas, and then we will return a result with an empty data struct in it. So we are not currently doing that, so that is why it's all red. So now this function should actually work. So the reason why we need a generic here is actually because we have all kinds of different canvas implementations, and we don't really care about the specific implementation of the canvas. We don't care about that it needs to be in this case, or that it is a cross-term canvas. It could be a Pixels WGPU canvas or something like that, which we have as well, or an image canvas, in memory canvas or something like that, that we are only rendering a frame buffer into to do something else with it. For example, save it as a PNG or stuff like that. So what this does is actually it will generate in the end one of those functions here for each type of canvas that we actually put in there in the code. Yeah, because their interface is always the same. We can always talk to them with a trait interface. Okay, so how would we actually render this pedal? I guess that would be kind of easy by simply doing a canvas filled rect, and now we need to, I guess, convert some things. So let's maybe put this into the next line. So the starting point would be, and as always, I forgot that I need a self-reference here. So what we actually want there is self position 0, self position 1. And yeah, I will need to say as I64, I guess, there in a second. So because the position can be outside of the drawing canvas for reasons like, for example, being able to move the field around and stuff like that. Then we want dimensions .0 as U32, as we already learned, and then we want self.dimensions.1 as U32, and then I guess we need self color, and we need this one as a reference, and then we can remove that and put that there, and then let's see. I guess this is already our rendering code. So let's quickly see. It should then now, yeah, there is our pedal at the bottom of the screen in the middle. Nice, nice, nice. So the next thing that we now actually need to do is we need to make it move. But first, maybe we can make the terminal a little bit bigger here. Oh, what did I do now? Yeah, so sorry, there I am again. I kind of crashed my terminal by prematurely terminating our application because we still haven't implemented the proper cleanup code that we need to integrate into it one day. But yeah, I've made it a little bit bigger here. So it's kind of the maximum that is possible to accommodate for this 100 by 100 area, so that you might hopefully be able to better see it. Okay, we were at the point where we had this pedal and we wanted to be able to move it using our key presses. So what we need to do for that is, I guess we need to check those in our update function. So what we simply need to do actually is, I want to be able to move it with my left and right cursor keys. So I say if input, come on, input is key down, keyboard key left. I guess then I want the state pedal move left. We don't have that function yet, but we will then implement it in a second. And if the keyboard key right is down, we want to move it right. So let's implement those two functions on our pedal, I guess. So pub, let's scroll up a little, pub fn move. What did I do there? Wait, what? No. It has been a long day already, so please bear with me if it's not, if I make some stupid mistakes or wrong button presses. So we want to move left, and we need a mutable self for this, definitely, because we want to change our data, the internal data. And I don't know, maybe we don't even return anything. Why should we? So if we are moving left, I guess we simply will do something like if self.position.0, because we only want to impact the x-axis, so we will only want horizontal movement, not vertical. If this is bigger than 0, we want self position.0 minus equal 1. And why are we checking actually the position? So that we can't move out of the screen to the left or to the right in a second, I guess. So I guess we can simply copy that. So move right, which would then be if the position is still smaller than our playfield width minus self width. Wait, no, self, sorry, we don't have self width. We have dimensions dot 0. So because we are always positioning this thing on the left edge, so yeah, this should actually work. Then we can actually add 1. And this should actually now allow us to move the pedal left and right. Let's see. Let's see. I can move it left and it stops at the left edge, and I can move it right and it stops at the right edge. Nice. So we can move our pedal in a terminal. With our PixelLoop engine. I already like that very much. I'm not sure. Maybe we need to allow for faster movement in the end. We will see once we implemented the play behavior. Okay, so I guess we have a pedal now. So I guess the next thing that we would need would be the ball. So let's create a ball. Is it called a ball in Breakout? I guess it's called a ball. If not, you know what I mean. So struct ball, which will actually have a position as well. because we need to know where it is. It's a usize. It will have dimensions as well, because, yeah, we need to know how big it is. It will have a color as well, because we need to know its color. And will it have anything else? Yeah, I guess it will, because when the game starts, or when you have actually lost the ball, so it got out of the screen, it will actually attach to your pedal, usually in those games. That's how I know them. So you can actually move them to a certain starting position before then clicking, or in our case, I guess, pressing space maybe. And then it will shoot out and go to a brick or something, and then you can start the playing. So I guess we need to track that somewhere. So maybe we need to have some information if the ball is flying or not. I guess we will need that, I guess. So let's maybe actually put it there already. Okay, so then, no, width, where did that come from? It was in my paste buffer, okay. So let's implement the ball. So what we need to do here now is a pubfn new again. So this thing will actually, yeah, take a position at dimensions as well. So no, wait, we could have a specific position, because as I've said in the start, it is positioned on the pedal. So maybe we should do something like we could put the pedal in. I have no idea if this is a good idea. Come on, if this is a good idea, what I'm doing here. So please bear with me if it's not, and we need to refactor this. But maybe we can put the pedal in there, and then it can determine its position based on the pedal. Yeah, that should actually work out. And then we need, yeah, width and a height, usize, height, come on, usize, and a color, which would be a color, and it will return a self. And now we can do, no, we are not using, we are not storing the pedal, so we are only calculating the position with it. So let's quickly do that. Let position equal, it would be the pedal dot position dot 0 plus pedal dimensions dot 0 by half. Which would then be the center of the pedal, and then we now need to subtract half of the width of the ball. So we want to subtract width half from that as well. So, and this would be the X position, and the Y position would actually be the pedal's Y position. So pedal dot position dot 1, and then we need to subtract the height of our ball, so minus height, so to place it just above. So this should actually be the position. Let's format. And now let's put that in there. So we have the position, we need the dimensions, which simply are taken by width and height. And let's put in the color there. And now this does not work. Why doesn't it work? Not sure. Ah, attached. Yeah, of course. And in the beginning it is attached, I guess. So yeah. So maybe we could give the ball a simple render function there, and we might be able to simply steal that from our pedal, because essentially it's the same thing. We are rendering a rectangle. So let's quickly take that, and we've called all those properties the same. What a neat coincidence. So this is actually not a problem. So essentially now we should be able to add a ball here. Call it ball. It's a ball to our state struct. And now I guess what we need to do is we need to create the pedal first, because we need to reference it in the construction of our ball. So this will be the pedal, this will be the ball. So we are doing a ball new, and let's put in the pedal there. Let's give it, for now, let's really give it a 1x1 size, and maybe a color of, no idea, from RGB, some yellowish color, yellowish orangey. Let's do a yellowish orangey color, something like 2551280. And then we need to put in the pedal, and this should actually create our state then. And now we need to render the ball. So as ball render just below the pedal render. So let's see if this actually works. Okay, so there is our ball, and yeah, of course it doesn't move with our, oh yeah, that's an interesting fact. It doesn't move with our pedal, of course, even though it is attached. So I guess we need to implement that. So let's implement something that actually moves or updates the ball. I guess we will need to update the ball any cycle anyways, because most of the time it will be flying. So we need to calculate where it is actually flying and move it around. So I guess we can do something like s.ball.update here. Not sure if we need any parameters, we will see. And then we will implement an update function of the ball. So let's do that. Pub fn update. And what would this update do actually? For now, if it has something like, no, and we need, of course, I forgot the self dot attached. So if it is attached, we actually need to move it along the pedal. So that means actually that the update function needs a pedal reference. So let's quickly fix that. So we need s.pedal here, and we need a reference to that. So that it can actually know where the pedal is. It will need that as anyways to calculate collisions, for example. So at least I guess so. At least if we are calculating the collisions within this update function, and I guess maybe we will see. So if it is attached, we simply want to take this calculation actually here that we already have. So we simply calculate the position based on self.dimensions.0 and self, and you can't see what I'm doing again, self dimensions.1. So we have taken this position calculation code, which calculates the position in the middle of the pedal, and then we simply say self position equals position. Which kind of, why does not work? Why doesn't it work? Cannot assign self position to, yeah, because we need a mutable self here. Makes sense, I guess, because the update function needs a mutable variable. Yeah, it updates our state. So let's see, maybe, if we start that, yeah, nice. Now our ball moves with the pedal. That's actually nice. Okay, so the next thing then, I guess, is that we need to be able to have the ball fly around. So I guess we should implement that. Where would we do that? I guess in the render function, in the update function as well. Yeah, I would say so. So I guess in case it is attached, we can now return here. And otherwise, we need to implement our ball bouncing update logic. So first, I guess our ball needs something else. It needs speed. It needs a movement speed into a certain direction. And the movement speed will be an isize by an isize. Because it can be negative. Yeah. Okay, so we need to actually initialize that, and when we are initializing that, I guess the speed is simply 0. So it's not moving anywhere, so the speed can be 0. Yeah, makes sense. Okay, so now we will actually need to make this thing move based on the speed. So essentially, this is more or less the same code than what we did before in our trivial example, having all those boxes bouncing around. We only need to move it with its speed every update, and once it hits a wall, then we need to handle that reflection, I guess. So yeah, so let's handle that. So what we are doing here is self position dot 0 equals plus equals self speed dot 0, and we are, yeah, this will of course not work because damn. That's a problem because we have now an unsigned value and a signed value there, and of course this could cause this one to get negative. Essentially, we don't want that. We want to reflect there, but I hope that we could actually do that check afterwards, because otherwise it's kind of messy. Maybe we'll do we will simply do something like we have a new position, and the new position will be self position dot 0 as isize, not usize, isize, plus self speed dot 0, and on the y-axis it will be self position dot 1 as isize plus self dot speed dot 1. So now we should actually have a new position. So this is our, let's call it new position, and let's now check if we need to change anything there before updating actually the new position. So if new position dot 0, so the x-axis can be the left or the right border, so it can be less than 0 or greater than the playfield width. So if this is less than 0 now, or it is new position 0 is greater than, and we need to calculate the playfield width minus self dimensions width actually. So if it's greater than that, then it means it's collided with one of the x-axes, so right or left. So in this case, we want self position, self speed dot 0 to be actually self speed dot 0 times -1. We want to actually kind of invert it. So what's the problem here? Playfield width, yeah, okay, so as isize. And this one is most likely to be an isize as well. Wait, what? No, there isn't a dimensions width. It's dimensions 0. Okay, so so this one should actually reflect it left and right. We will fix up its position in a second because it might be currently outside of the screen. And now we need to do this for the top border, so the top screen border. So if new position dot 1 is less than 0, so let's maybe put that here, left plus right, and this will be top. So if it is less than 0, then self.speed.1 equals self.speed.1 times -1. Okay, so let's invert it then. And now the interesting part, which is the bottom, because if it hits the bottom there, we want actually to reattach it to our pedal and stop the game for now, so that we can actually fire it again. And we most likely would like to decrement life or something like that in the future. So if new position dot 1 is bigger than playfield with minus self dot dimensions dot 1, then, and we need this as eye size. Then we actually want to self attached true, and we want self speed to be 0 again, because we don't want it to move. Yeah. Okay. And now we need to fix over. Why am I caps locking all of this? Fix overflow positions. So what we need to do now is we need to make sure that the positions that we might have overflowed are not a problem. So let's actually see. We can do this when we are updating the position. So the 0 position should be the new position dot 0, and it should be clamped between 0 and playfield with. Yeah. And once we've done that, we can actually say it's a U size, because we are sure it is the right size, and here we need it as an eye size. Yeah, as I've told you, it's a lot of conversion-y stuff there due to the different sizes, and maybe I will refactor the PixelLoop thingy in the future to have other sizes, other types. So this would then be clamped between 0 and the playfield height. Yeah. So now it should actually assign and fix overflow positions. So what we need now is we need some way of running this routine. We are already calling it every update cycle, but we need to be able to detach the ball. So maybe let's do something like define a new input here. So if input is key pressed, come on, pressed, keyboard key, and maybe we will simply do space here. So if the space key is pressed, then I want the ball attached to be false, and I want the ball to be not, and we need to set a speed, I guess, an initial speed. So for now, let's just shoot it straight up, or let's for now move it like -1, -1, -1 or something. So to diagonally to the left. So as ball speed. There I was. So, okay. So let's see what actually happens if we run that and do that. So I should be able to move that. Okay, I am. So now if I hit space, okay, the ball is actually flying there. And once it hits the bottom, it will reset. Yeah, that's actually, yeah. The thing here, of course, is that it doesn't compute hits to the pedal yet, but it computes hits to the walls. So yeah, this actually works. So that's a good start. So we have a flying ball, and most likely, I guess, what we would want here in the end is that the ball always goes straight up until it hits the pedal again. But so let's maybe, yeah, let's maybe do it like this for now. Straight up. Okay, so then let's think. We now need to actually calculate collisions with the pedal. Where would we actually calculate collisions with the pedal? Would we do that within this update function of the ball? I guess, why not? So, yeah, I mean, we have the pedal there, so why not? Let's do that. So, maybe here. So, we have the pedal position there. So, if the ball, if self dot, let me quickly think. If new position dot y. Let's first of all x. Let's check the x position first. It needs to be within the x position of the pedal. So if the new position on the x-axis is bigger or equal to the pedal position dot 0 and the new position dot 0 is less than or equal to the pedal position dot 0 plus pedal dimensions dot 0, and I guess that this then would it be correct like that? Yeah, it would be. It needs to be less than or equal, I hope, I guess. So if that's the case, and the y position and new position y 1 is bigger or equal to the pedal position dot y. So this is already the upper corner of this thing. So this would actually be fine here, and I guess we need to do as I size and as I size. And if that's the case, pedal collision, then it actually collided with the pedal. So what we need to do now is we need to kind of reflect it off that pedal. And what I'm thinking about is that according to where on the pedal it actually collided, I want it to be reflected with more drift to the corresponding side. So what I want to do here is I want to do something like, okay, first I guess we will need to calculate the distance of our impact with the pedal. So that would actually be new position dot x, and we want to subtract the pedal we want to subtract the pedal position from it. Yeah, so pedal position dot 0. So this should actually give us the amount of pixels that we are into the pedal. And now I guess what we want to do is we want to calculate a scale value between 0 and 1 of this position. But I guess we want to calculate this with regards to the middle of the pedal. So let scale equal new, distance divided by, as F64. Now we are in floating point domain. And yeah, there might be a nice way to do this all in integer domain, but let me just make it work for now, and then we will see how we can make it better. So so there is distance divided by, and then we need pedal dot dimensions dot 0 divided by half. So now we should actually have the way we are from 0 to 1, we are from the middle of the pedal. But I'm just thinking, do we really need that, or can we do the full thingy there? We can actually do the, let's not do this division, because we might lose information there that we actually need. So let's do F64 here. And then let's take all of this, and then let's multiply it by 2 and subtract 1. So now we have a value between -1 and 1. That's actually kind of nice. So this will be the scaled position or scaled distance. And this is not working. Why? Oh, because I need point. Yeah, makes sense. So, and what we now can do is we can actually determine how many steps we want. I guess maybe the fastest that we can go is something like 3 pixels to the right or to the left, and 1 for 1 up. That would be kind of a, yeah. So let y speed equal scaled distance times 3, and now we are converting it back. And we are rounding that, and then we are converting it back to an eye size. And then must be a dot 0. Okay, so what we now can do is we can say we want to move this thing self speed. We want to move it up. No, we want to move it the y speed. It's, by the way, it's not the y speed, it's the x speed. It's the movement on the x-axis. So this will be x speed, and we want to go it up in the y direction. Okay, so now let's see if I've done that actually correctly, or if it's a horrible shit show. We will see. We'll now have to kind of hit it here, and it goes to the side. That actually looks kind of right, and it even hit further on the edge, and it was even faster. So if I hit it just slightly off, it should, yeah, it is a little bit slower, I guess. Okay, yeah, okay. This actually seems to work, because if I hit it more or less in the middle, it goes right up, and otherwise it will go faster or not so fast to the sides. And if it misses, it goes back to its original position, and I can start it again. Okay, this actually is quite some progress. We have now collisions based on the pedal. So now we need some bricks to collide with, so that we can actually create really a game of Breakout. So let's implement some. So we need a new struct. We need struct brick. And this thingy will have a position again, which is a u size by a u size, and it will have dimensions again, which is size, and it will have a color, which is a color again, and it will have some flag if it's destroyed or not, I guess, because somewhere we need to handle that. And then I guess I can mostly copy some stuff over here. Let me see. Like the new and the render function from the pedal maybe. So let's go impl brick. So does a brick need a pedal? No. Does it need a width and a height? Definitely. Does it need a color? Yes. It needs, however, it needs a position as well. So maybe an X and a Y. So that the position now is X, 1. I guess I can inline that. So the position will be X, Y. The dimensions, it doesn't have a speed, and by default, it's not destroyed. So there we go. We have a new function for our brick, and now the render function mostly is the same. I guess we will see if we need to render it differently if it is destroyed. Yeah, so now let's give our state a couple of bricks. So this will be a vector of bricks, I guess. And let's maybe initialize those. Let's maybe put 1 in there just to see if we have everything all right, and then we can, after that, create them programmatically somehow. So what we want here is a new brick, which is, I don't know, at position 5, 5. It has a width of 7 maybe, and a height of 2, and the color is new from RGB is something like 25548 128. I've actually no idea what color this is. We will see. Maybe it's a nice color, or otherwise we change it. And now we need to, of course, render our bricks as well. And I guess we want to render all of our bricks first. So for brick in S bricks, brick dot render, and I think we need to give it a canvas reference, and I think we might need to do that and that. What's the problem there? It may return a result there, and then yeah. Okay, so let's see if it is actually rendering this one brick. Okay, so there we have a pinkish brick. Okay, fine for me. Okay, so now let's create more of those, first of all, before we implement collision logic. So what I want to do here now is I want to take, where is my state? There. So what I'm doing now is I'm taking this one out, and I want an empty vec there for now. And then when I'm creating my state, I'm creating it as a mutable state. And I guess then we can do something like y in, how many brick layers do we want? Like, I don't know, maybe 8 or 10. And for x in, how many would fit there actually? 100 divided by, what did I do that? 7, and let's maybe do 2 spacing between them. So that would be actually 11. So yeah, why not? So 0 to 11. And now let's create some bricks, I guess. That would be state.bricks.push brick new, and wait, didn't I, yeah, I did copy this when I cut it out. So let's remove the vec call here so that we have the color there. We now want position 5 plus y times 2 plus 2. So the width, maybe let's, for making it easier to change, I would like to factor that out. Let's format this for now. So yeah, I'm not sure. So the starting point is 5. Then we want y times 2 plus 2, which is the 2 height plus 2 spacing. And then we want the position to be 5, the starting point, plus x times, what was it, 7 plus 2 spacing there as well. Then we have the width and the height and the color, and yeah, let's see if this works and generates a layer of bricks. Okay, this did not do what I expected to do actually. What did I do wrong there? That's kind of strange. I would have thought that. Wait, what? Oh, because I've done it the wrong way around. Okay, so yeah, okay, so this looks actually quite nice, but we have one too many. So let's just reduce this and let's make a 10 by 10 grid. Yeah, okay, so this looks fine for me. So we have some bricks. We could do them, or we could create them in a more colorful way maybe, but not interesting now. Just let's get going there, and then we can do some more color stuff there. Okay, so maybe random colors and stuff like that. Okay, now we have a couple of bricks. Now we need to implement collision, I guess. So where would we do that? We could implement that with within the update function of the ball again, but then we would need to put all the bricks in there. Yeah, as I've said, that may need some refactoring, but for now let's do something like we are in the wrong function. We are in the render function, not the update function. Maybe before even updating the ball, let's do a collision check with the bricks. So for brick in in reference to s.bricks, if brick collides with ball, and we give it a reference to our ball, to s.ball, then we want to brick destroy, maybe something like that. So two functions that we need to implement. Yeah, I guess so. And we don't only want to destroy the ball, but what we want to do is we want the brick, we want to change the direction of the ball. So s.ball dot speed, and maybe we can simply invert the the y movement. Equals s.ball.speed.move -1. So this might actually work. So where's the problem here? Unexpected token. Wait, what? Why? Okay, it may be unexpected token. Oh yeah, because I've missed the semicolon there. Yeah. So we need collides with ball and we need destroy. Destroy should be reasonably easy. Let's do that first. So pub fn destroy, and it needs a mutable self, and it simply does self destroyed true. And I guess then I want to, if self destroyed, we could do something like render it with a lot less intensity or make it disappear altogether. I guess for now we simply make it disappear altogether. So in case it is destroyed, we simply do not render it. Okay, and now we need collides with ball. Pub-fn collides with, I'm not sure if is it 2L or 1, no idea. Not that important now. Ball. So this will be a reference to a ball and it returns a Boolean. And I guess we can return something like, do we even need a return here? Not sure. We will need certain conditions to be met. So we can actually more or less take the collision detection we implemented in our update function for the pedal, because it's essentially one part of it. So let's take that and let's simply steal it. Collides with ball. So if the, and that is if the ball dot position dot 0 is bigger or equal to the 0 position of our, and we need of course again a self-reference here, which I've missed again, our own position, and I guess we don't need those now. And the ball position dot 0 is less than our own position plus our own dimensions. Then we don't need those braces there as well. And if our ball position 1 is bigger than the self position 1, and now we need a fourth condition, because the last time it was enough to check that we collided with the with the pedal from the top, but we might collide with the bottom. So so ball position dot 1 needs to be less than or equal self position dot 1 plus self dimensions dot 1. Yeah, I guess so. So is this actually, no, we don't need and we don't want either an if there nor a semicolon, because this is our condition returned. Is this actually correct? We will see in a second. Maybe I've done something wrong there, but we will see if it's colliding now. Okay, it doesn't even compile. So so let's see what doesn't compile there. It's the brick and it cannot. Yeah, okay, that actually makes sense. So what I need to do is I need an iter mut here, I guess. Yeah. So now the moment of truth. Let's see if we can actually remove. We can actually remove a brick. Oh, okay. We're colliding with a ghost brick now. Okay, let's quickly fix that, because when we destroy the brick, we can still collide with it. So collides with ball. So what we need as well is self.destroyed destroyed. So we only want the collision detection if it's not destroyed. So let's see. I guess maybe we have ourselves a breakout game now. Okay. So let's see. I think I can. I think I can play Breakout now. It's kind of playing itself currently. But yeah, that's more or less how Breakout often functions. Usually the levels are more complex and not just that simple set of bricks where the ball can bounce around in, and this works actually quite well. And there I am, have lost. Yeah. I think this this works out quite well. We implemented a breakout game. So while I'm trying to play this here, thank you for coming along with me. We have now a breakout game in our terminal. I will, as always, post the link to the GitHub in the description below. And yeah, I hope that when you enjoyed it, you will like the video and you will subscribe. And if you have any questions or any comments, please leave me such thing as a comment, and I will try my best to answer it. And yeah, and I hope you had fun, as much fun as I had implementing this thing here. And I hope to see you in the next one. So yeah, bye.